Sometimes we have a three-dimensional solid like the one shown here, and we know what the volume is, and our goal is to try to figure out what are the dimensions of that solid. Now, if we look at this, it's not a traditional solid. It's not just a prism. It's not just a cylinder or a sphere or anything that we know. It's a combination of various things, or it's a solid that has a piece cut out of it. If I look at finding the dimensions here, I would probably want to say, let's expand this solid into a larger one and then take out that chunk. Because if we look at this, if I try to cut this, let's say I try to cut it right here, I know that the base is 80, I know that the depth is 10, but I really don't know how tall this is right here, and I can't figure that out. And if I try doing it the other way, if I try going this direction, I know that the height is X. I don't really know what the width is, and I do know that the depth is 10. So I'm missing a dimension each way if I try to go that route. So instead, what I'm going to do is I'm going to extend this out so that I have a larger prism. So if I look at that entire thing, I know that the width is 80, I know the depth is 10, and I know that the height is X. So if I look at the large prism, I can say that the volume of that would be 80 multiplied by 10 and multiplied by X. So if I multiply those together, the 80 times the 10 gives us 800, so I have a total of 800x for that large prism. Now, if I look at this addition that we had, so small prism, its volume, I need to know the length, the width, and the height for that. Well, I've got the length here, I know the depth is 10, and I know the height is 40. So I have a 40 by 10 by x, which would end up giving us 400x for that volume. Now, if I'm looking at the actual shape, let's say we go with purple here, to find this shape here, the L shape, I'm going to take the difference between those. I'm going to take that 800x, subtract off the 400x, because this piece right here is being cut out of that larger prism. And that ends up giving me 400x. But we know that volume listed in the original problem was 24,000. So I'm going to put that as the solution to this equation. So now if I want to try to solve that, I'm going to divide off the 400 off of both sides. And if I take that 24,000 and divide it by 400, I end up getting x equals 60 millimeters. So sometimes we're able to take a three-dimensional solid, and instead of breaking it down into smaller pieces, sometimes we need to expand it to a larger solid that then we can take out a piece. And the reason that worked out here is because we had the dimensions of the large solid. We knew the dimensions were x, 80, and 10, and we knew the dimensions of that additional piece that we added on were x, 10, and 40. And that allowed us to find the volume of that outside prism and to find the volume of that additional piece so that we could find that dimension, that missing dimension of x, which is what we're ultimately trying to find.